In this open-ended design lab, you will be designing a common emitter amplifier. The first step is to derive formulas for voltage gain, input and output resistances. Now, in this circuit, you're given the values of RC and RE, but you will design the values of R1 and R2. You will use Multisim in order to figure the values of R1 and R2. So what you need to do in Multisim, you need to run a DC sweep analysis using this circuit, where you tie a DC source at the base and you vary between 0 and 5 in small steps, and then you are plotting the collector emitter voltage, and the criteria is that the VC should be equal to VCC over 2. So in order to do the plotting, you need to adjust the DC sweep parameters as shown. And on the output tab, you need to select the collector emitter voltage. Since you don't have collector emitter voltage available, you need to select base the collector voltage and then base the emitter voltage, and then use some math to get the VC voltage. In order to plot VBC and VBE voltages, which are used in this equation, you need to click on Add Device Model Parameter and then select the transistor base collector and base emitter voltages, and then use this expression to get the collector emitter DC voltage. Now this is just an example, so you're seeing that the cursor is placed right at VCC over 2, and then you're figuring out the base voltage needed. Now this one's showing something like 2.5 volts, but you will get something close to 2 volts for your circuit. And once you found the voltage at the base, then you're gonna design R1 and R2 resistors. So you got 9 volts, so you need to get something like 2 volts using this voltage division network. There's one criteria though, you have to have R1 in parallel R2 more than 1K, so we don't want you end up using very low resistors for R1 and R2. And then you have designed your amplifier. We want you to run the amplifier and calculate the voltage gain in Multisim, so you can tie an AC source such as 10 millivolts peak and a midband frequency, and then run a transient analysis to find the actual gain value. Now, before we're heading to the experiment part, we want to do a hand calculation of voltage gain, input resistance, and output resistance. We have R1 and R2 resistors now known, and we are giving you a beta of 140. You can easily figure out the value of IC, the collector current, because since we got the VC at 4.5 volts and the values of RC and RE known, so you should be able to figure out the value of IC and then draw the small signal equivalent and figure out the voltage gain, input resistance, and output resistance. The input resistance of this amplifier is R1 in parallel R2 in parallel R pi. Note that RE is grounded by the bypass capacitor. And similarly, the output resistance of this amplifier should be equal to RC roughly. So once you do these calculations, then you can proceed to the experimental part where you construct the circuit and you recalculate the voltage gain after tying a 10 millivolt peak source, an AC sinusoidal at midband. And then you need to, on part 3, find an experimental procedure to determine input resistance and output resistance. One idea is to use this arrangement to determine the input resistance experimentally. So here is your amplifier shown in this triangle. So what you're applying is an AC source with a 1K or a moderate resistance. So what you do is simply measure the voltage seen at the amplifier input. And then if you notice that when you apply 100 millivolts, you're getting 50 millivolts, then the input resistance should be equal to the 1K, since the voltage is dividing equally. So you can simply apply the voltage division principle to figure out how much resistance you're seeing right there. And for the output resistance measurement, you can simply tie an input source, very small, to excite this amplifier. And then at the output, you connect a variable resistor in kilo ohm range. So prior to connecting this variable resistor, you first calculate the output voltage. Then once you connect, you vary it until it reduces to the half of the previous that you measured. So before connecting, assume you measured 4 volt peak to peak, and then so once you vary this and make the output voltage reduce to 2 volt peak to peak, you simply remove this and measure with an ohm meter. So then you will get exactly the same value as this peak RO.